Yes, so good afternoon. I'm Jeff Hammerlink, Associate Director of the School of Computing and Director of the Wyoming Geographic Information Science Center here at UW. It's really my big pleasure to welcome you here today to the second annual Geringer Distinguished Lecture in GIS and Public Policy. Yeah, such a great turnout for a Friday afternoon, and great to have people in the room, great to have people online. So it's a exciting time. Last year we started something new at the intersection of GIS and decision making. You know, GIS and Geographic Information Science and Technology, has had an impact in public policy process really since GIS began back to the 1960s. Over the last 50 years, there have been advances in the development and availability of both geospatial technology as well as geospatial data. And that's really paralleled a growth of data-driven planning and decision-making models that have fed into policymaking at all levels of government and industry for that matter. Today more than ever, successful public policy depends on high-quality data and technology, both old and new, from maps to AI, that both interpret, it's really necessary for these things to be able to interpret data fully and accurately, and also communicate its meaning effectively so it can have that impact in decision making. This annual event has been established in the name of the Honorable Jim Geringer, Wyoming's 30th governor. Jim has long been an advocate for the power of geospatial, building on his early experiences in the Air Force and production agriculture, and continuing on as his time, during his time as a state legislator and as governor of Wyoming. After he left office, he continued for an extensive period of time, almost 20 years, working in the private sector and in service to advancing the U.S. national spatial data infrastructure. We're honored that Jim agreed to lend his name to this annual event, as well as deliver the inaugural talk that we hosted last year, and I know that many of you are here for that. Jim was looking forward to being here today. He knows Barb well. Unfortunately, Jim's wife, Sherry, is in declining health, and Jim's priority today is to be at her side, as he has been for more than 58 years. So, yeah, please keep Jim and Sherry and their family in our thoughts today. So a few acknowledgments that I just want to make. Takes a team effort to launch and establish an annual event like this. I just want to acknowledge my colleagues at the UW School of Computing. Got the best admin team ever, especially for this event. Lana Chavez, Tim Musselman, Judy Yates really went above and beyond pulling this together. Also, really a shout out to the leadership and support of SOC Director Gabrielle Allen. Gabrielle was open to having a conversation with me 3 years ago about the great opportunities that existed in making WYGISC a part of the School of Computing, and she continues to support geospatial as part of applied computing across campus today. I can't think of a better place, more forward-looking place for WYGISC to be than in the School of Computing right now. So that's the team. As far as others that have really helped to move this forward, I want to thank the UW Foundation, Teddy Friedman, Major Gift Officer that helped us get this off the ground over the last couple of years. The Wyoming Geospatial Professionals Organization really helped jumpstart the campaign to turn this into an endowment that would be self-sustaining, really making contributions there. So thank you, YGO. And then all of the folks that have given over the last few years to the WYGISC UW Giving Day contributors. It's really because of you folks that we're able to actually move forward and making this a truly special event every year. If Barb would have known I was talking so long, you would have sat down and waited. and now to get to an opportunity to introduce today's speaker. Today, it's my pleasure to introduce Barbara Ryan. Earth Observation Advocate, as the presenter of our second annual Geringer Lecture in GIS and Public Policy. Barbara's accomplishments resonate really just perfectly with the spirit of the Geringer Lecture, and we're really excited to have her here today. Under Barbara's leadership, millions of satellite images and other Earth observation data have been made available to the general public at no charge, really moving forward that idea of open data and open science, allowing scientists, planners, and policymakers to make better informed decisions on problems that transcend political boundaries. Her work addresses critical issues in agriculture, biodiversity, climate change, disaster planning, energy, health, and water. Barbara's career has included a long affiliation with the U.S. Geological Survey, where as Associate Director for Geography, she was responsible for the agency's remote sensing. She'll tell you it was a team effort, and we know that it was, but your leadership was key in that. Responsible for moving the remote sensing, geography, and civilian mapping programs forward, including Landsat satellites. From 2008 to 2012, Barb was director of the World Meteorological Organization Space Program. From 2012 to 2018, she was the Secretariat Director of the Intergovernmental Group on Earth Observations in Geneva, Switzerland. And then kind of capping off her career, although I know she's still a very busy and active person in the industry, Barb served as the second executive director of the World Geospatial Industry Council, a not-for-profit trade association of private sector companies working in the geospatial and Earth observation ecosystem. Barb's recognitions by her peers in the industry are many and well-deserved. She holds an honorary doctorate of science degree from her alma mater, the State University of New York at Cortland. She's an honorary fellow of the American Geographical Society, a 2017 member of the Geospatial World Forum's Hall of Fame, and in 2019 was recognized by the Department of Interior and NASA with their Picora Award. We're honored and delighted to have her with us today. Please join me in welcoming Barb Ryan.
Thanks, Jeff. Hey, thank you very much for that kind introduction. Hey, it's an absolute honor to be here. When Jeff called and said that you guys had established a lecture series in Governor Geringer's name, I mean, really, tears actually came to my eyes. Jeff, many of you won't know this, but when I was with the U.S. Geological Survey, it had to be a change in administrations, and a Republican president was coming in, and several of us at the USGS, put a full court press on Governor Geringer. We said, please come back and throw your name in the hat for Secretary of Interior. You are one of those few policymakers that fundamentally understands geospatial data. We might have said mapping data at the time, or Earth observations. And to your point today about his wife, he said, no, we're pretty happy here. Both of us like it here in Wyoming. And I guess I'm not too interested in going back into Washington, D.C. and all that fray. But we could think of no better Secretary of Interior if he had put his name in under that administration. So thanks for the invitation. I guess Jeff maybe said some of it, but I've got a next slide I've used a couple times, and we'll do 72 years and 72 seconds. First of all, Nick, born in Dalton, New York. That's near Letchworth State Park, Grand Canyon of the East, one of those few rivers in New York State that flows north up into Lake Ontario. And what's so interesting about it is I didn't know it until I worked for the U.S. Geological Survey. John Wesley Powell was born in Mount Morris, New York. So he was at the northern end of the park. We grew up about 3 miles from the southern end of the park, and I never would have known we had that kind of connection from upstate New York, Western New York, with the Geological Survey. So a couple degrees, geology, State University of New York at Cortland, geography at the University of Denver, and then went back on a survey sabbatical program for engineering, civil engineering, water resources engineering at Stanford. And then, of course, I did serve on the Jane Goodall Board of Directors, the U.S. unit, for a long time. And so when I put it up here, I'm obviously a little embarrassed to say 72 years, but I'll tell you, Jane Goodall is something like 91 years of age. And at the time this picture was taken, she might have been 85, I guess. She was traveling 322 days a year for her effort. 300, I have never traveled, Brian, you might have, I've never traveled 322 days in any given year. So talk about energy, it's just unbelievable. And in fact, when I was on the board, it was pre-pandemic, because she went during the pandemic, COVID, she goes back to England, I've forgotten the name of the town where she was born, in the house she grew up in. She had not spent 2 consecutive weeks in that house for 34 years. She had not spent 2 consecutive weeks at home in her house for 34 years. Talk about energy and passion for getting her life's passion out there. And obviously family, I've got 2 wonderful grandchildren. They're quite a bit older than this photograph down in Colorado Springs. So I really appreciated the trip out west too, so that I could see them. What Jeff told you about the largely 4 organizations that I've worked for, 34 years with the Geological Survey, 10 years combined in Geneva, Switzerland, 4 with WMO. And so for many of you who don't know WMO, it's the UN organization that's responsible for coordinating atmospheric and weather observations. So just like the World Health Organization coordinates health departments around the world, WMO does the same thing for the weather agencies around the world. And then the Group on Earth Observations, it's an intergovernmental group. We were housed in the WMO building. It is not a UN organization, but but all the money came from governments to fund that effort. And then lastly, the World Geospatial Industry Council, which is a not-for-profit organization, but it's coordinating the efforts of commercial companies that are working in Earth observations and geospatial data. So honestly, in each one of those assignments, I think the underlying thread was that we're stronger together than apart, and we've got to look for synergies among each of these institutions, whether it's in the federal government, some international governance mechanisms, or the commercial sector. So that's that. And a couple of the stories that I'll talk about, I tried to pick kind of a good news story about the importance of Earth observations that will build this digital twin and metaverse story for the whole talk, okay? So the overview of the talk, I think spatial digital twins present just an unbelievable opportunity for creating a truly virtual representation of the Earth. I would call that the metaverse. I think the gaming environment has kind of captured this whole idea about the metaverse, and this is to take nothing away from gaming. Some of the great advances, I would argue, in geospatial data have actually come from gamers working in this area. Hundreds, millions of hours are spent by people around the world gaming. A lot of money is going into that. But somehow we only think about the metaverse as a gaming environment, when in fact there are digital twins of our brains, our bodies, this room, the building, the campus, the state, the country. Europe wants to build one of the entire Earth. And I can tell you every single presentation I've seen on a digital twin doesn't talk anything about boundary conditions. It's all contained to just my brain, you know, the 4 rooms of this wall. And yet the power is in the linkages or the interstitials or those boundary conditions. And yet we don't integrate them. And so if we were to integrate them, I think that is a true virtual representation of the physical Earth that we live on. So that's the second point. It really could be a forcing function that I think we so desperately need to address the issues that are facing us today. There is a greater need for collaboration among governments, among the commercial sector, among academia. The long-term investments that are being made by government certainly provide continuity and consistency of observations over really broad, national, global scales. These are essential investments. And yet the capabilities of academia and the commercial sector really do provide just much needed depth, specificity of scale. We've got to do a better job of kind of linking those. So that's an overview for the whole talk. As we kind of look at these individual case studies, I think it had to be in 1980 or 1990. I came across this image. It's a Landsat scene. Ramesh could probably tell us what row and column it is from the Aeros Data Center. And you would think this is two Landsat scenes side by side. No, it's one. And it points to the different land management practices that we had in Targhee National Forest and also Yellowstone National Park with some burn scars there from historic fires. So right then we have a data set from the USGS and NASA with Landsat that actually shows human behavior and the choices that we make on the landscape. And nothing could be more visible than that really sharp boundary between those two property owners and land managers. That kind of will lead us to the story that some of you, Ramesh in particular, know about this. The first Landsat satellite was launched in 1972. And so NASA builds and launches the satellites, the whole Landsat series. The US Geological Survey operates the satellite. So as soon as they are successfully on orbit, ownership turns over to the US Geological Survey. And so from 1972 to 2008, the US Geological Survey sold Landsat data. $450, $500 a scene in the mid 1980s when the commercial sector, we were going through a privatization era and the commercial sector took over. The price per scene maybe jumped to $4,000 or $5,000 a scene. It wasn't sustainable, obviously. So it comes back to the US Geological Survey to continue charging $400 or $500 a scene. Now, we were taking in $5 million a year for the sale of Landsat data. That's not chump change. You know, for a federal agency, $5 million is a lot. So it's not like the Geological Survey wanted to give up that $5 million of money that was coming in. But we looked at who's buying the data. So number one, we were selling 53 scenes a day at, so that costs $450, $500 a scene. So that'll get you your $5 million a year. But who's buying the data? Number one, other federal agencies, largely the Department of Agriculture, but BLM also, Forest Service, federal agencies. Number two, next, universities. Where were they getting their money? Largely from the National Science Foundation. And number three, the commercial sector, who was getting its money from the defense and intel community, largely for processing Landsat data. So we said, you guys, we are taking federal money from this pocket, we're putting it into this pocket, and every single one of those agencies or organizations is incurring administrative costs to process the sale and the receipt of that money. It's nuts. It's absolutely nuts. So while many people were talking for a long time, NASA in particular, from 1972 when the first satellite was launched, this data ought to be broadly and openly available. We don't say free because the citizens of the United States had spent hundreds of millions of dollars launching 9 Landsat satellites. The distribution costs, the employment costs associated with that, how many billions of dollars do US taxpayers have to pay? And then you're going to charge them $500 a scene for Landsat data? This is nuts. So it was under a Republican administration that we were finally able to tell this story. And we said, listen, we think what's going to happen as soon as you get it out over the web is this download issue is just going to skyrocket. We didn't know that it was going to go up 2 orders of magnitude from 53 scenes a day to 5,700 scenes a day, but it did. And of course, that data is downloaded globally. So tremendous usage of Landsat data with this change of policy. But the real story in my mind is that an economic analysis was done in 2011, and it showed that the benefit of that, I had left the organization by then, I retired in 2008, The economic benefit to the US was $1.7 billion, $400 million outside the US, for a global total of $2.1 billion, far exceeding the $5 million that the Geological Survey was collecting for the sale of that Landsat data. And then just a few months ago, maybe this says 2023, but I didn't think it was that long ago, another economic analysis was done of that policy change, and that whatever the number was before, was it $2.1 billion, went up in order of magnitude globally of $25.6 billion of economic return from that one policy change. So really quite substantial. But listen, this is one satellite series. This is one metric of, one observation for the entire Earth. Can you imagine if, and we're lucky here in the US because all the streamflow data is mostly broadly and openly available, but what about the soil moisture data? What about all of our atmospheric data? What about all the geospatial data that is collected by the government? What we were arguing is the private sector is going to have its own data policies, they're in it for other reasons. But from a government perspective, the citizens of this country have already paid for the data. They've paid for the people that are collecting the data. They've paid for the collection devices. This data, all of this Earth observation data, needs to be broadly and openly available at the state level, at the city level, at the federal level. And we would have a much better understanding of our Earth system if that data was not so hard to get a hold of. So that's the economic benefit for Landsat. This next slide is building on that, but I didn't hear about this application until I went to Geneva, Switzerland, and it's what Australia calls their, oh, now, Tom, maybe I am gonna need, if I hit that, if I hit it. There's audio with it, you guys, so I think I'll just be quiet and let you listen for just 2 minutes.
The Landsat series of satellites has been acquiring detailed 25 by 25 meter pixel images of the Earth's surface since the 1970s. To manage the large volumes of Landsat imagery covering the Australian continent, Geoscience Australia, in collaboration with the CSIRO and Australian National University, have developed the Australian Geoscience Data Cube, a geospatial cataloguing system run on the National Computational Infrastructure Supercomputing Facility. The Australian Geoscience Data Cube keeps every pixel of data or every observation as calibrated measurements with the cloudy areas removed. This system takes all the Landsat seen since 1987 over Australia and divides them up into tiles, making the imagery easier to access and analyse. This means that all of the Landsat data stored in the cube can be used, interrogated and manipulated at any time by accessing the cube anywhere over the continent. Running this system on a supercomputing facility makes it possible to generate detailed environmental information at continental scales. One example is the systematic detection of surface water. Each image is processed to work out where, in each observation, water covers the landscape, allowing us to see features such as lakes and rivers empty and fill over time. The water data is then aggregated into a single map showing the frequency of inundation as shown in the water observations from SpaceMap. This product shows how often water was observed by the Landsat satellites over the entire length of the archive for the entire country.
So what's important here is, and they now also have ingested the entire European data from the Copernicus series of satellites, those Sentinel satellites. What I think is, yeah, that's the picture. I pulled that off YouTube, you guys. So we'll go back to that one. What's amazing is Australia doesn't have its own satellite, and yet they, more than any other country in this world, have exploited Landsat data and Sentinel data, I think, much better than we have here in the United States, because one, they're kind of isolated. It's out there. It's quite a ways out there. But the collaboration that occurs between their National Computer Center, CSIRO, a research institute, and their space agency for kind of downloading data has just been miraculous. And so this move to the computing department, I would argue, it opens potential for bringing people in, to quote Jim Gray, former, well, he no longer with us, but he was the chief researcher at Microsoft. And he just said, they're ones and zeros. That's all we got to think about are ones and zeros over this entire thing. And yet we get so hung up on our individual attributes for these. I think we just need computer technicians that kind of look at ones and zeros and how we can do a better job of kind of managing this whole asset. The issue with Australia was, yes, it's a country, but when I was in Geo argued, but it's a continent. So why don't we have the same capability continent by continent? They are migrating it to Africa right now. Some additional challenges that are there. And I happened to be with Alex Held, one of the engineers of this project a week ago. That was the Heathrow incident travel when we were in the UK. And he said, I'm kind of frustrated with this continental approach. Maybe we just have got to kind of break it down and start building it from the ground up. So in one of the meetings, sidebars that we had today, when we talked about it, I said, wouldn't it be wonderful? It's particularly with the genesis of all of geography and computing being together. And you've got NCAR down the street with a gigantic capability. What if Wyoming had its own data cube? And this is just a water layer on top. So this is just what was wet, what was dry over the last 40 years. What if it was land cover? What if it was urban development? What if it was forest fires? I mean, all of a sudden you would have at your fingertips any landscape change that has occurred here over the entire history for which we have data. In this case, it's likely Landsat data. So anyway, that's a story. Broad open data policies. I guess the only other thing I would say, and this came up in one of our later conversations, it took a village. There were many people, like I said, back to well before I joined the organization, about advocating for broad open data, but it took a political appointee to carry the ball over the finish line. Okay, it wasn't us as career scientists in the Geological Survey. We had to get political support for this to go forward to the president and say, hey, this is the deal to do. So I would argue that my boss at the time was Mark Myers, and his boss was Dirk Kempthorne, and it was those two people that really had to step up and get it over the finish line. So that's that. Oh no, we're not doing that again. Okay, let's switch over to WMO real quick. For me, this is one of the best Earth observation stories that nobody knows about. This is from the European Center for Medium Range Weather Forecasts. And it's improvement in medium range forecasts. What you'll see are a couple different things, but we'll dissect it. Blue is the 3-day forecast. Red is the 5-day forecast. Green is the 7-day forecast. And yellow is the 10-day forecast. So a couple things. The top of the line is the northern hemisphere. The bold is the northern hemisphere of any color. The bottom of the line is the southern hemisphere. So what you can see is that our northern hemisphere observations have always been more accurate than our southern hemisphere observations, largely because there's not as much land mass for our collection systems, all of our weather stations in the southern hemisphere. So it was heavily dependent, of course, on satellite-based observations later on in the 90s when those lines started coming together. But northern hemisphere estimates have always been better. What we see in 97, 98, 99 is the introduction of satellite space-based measurements of our entire weather system. And really, quite remarkably, the improvement between the northern hemisphere, the distance between the northern hemisphere, accuracy between the northern hemisphere numbers and the southern hemisphere numbers come together. So in the southern hemisphere, particularly at a 3-day forecast, they're almost the same. The accuracy of the northern hemisphere estimates, the accuracy of the southern hemisphere estimates are about the same. Obviously, when you get down to this 10-day forecast, you know, even that northern hemisphere estimate is really only good out to about 40%. So really, it was largely the introduction of space-based observations with in situ measurements that have told this Earth observation study. And again, this is just one data set. This is just the global efforts of all the weather services around the country, around the world that share data. But can you imagine if there were another metric where we were trying to look at global scales and actually looking at merging data from both in situ measurements and satellite-based measurements? So mostly it's only the weather people that know about that story, but I think it's a phenomenal story of international collaboration to deliver better estimates and save lives because of those estimates. You know, go back and just one more thing, look at red, which was the 5-day forecast. Take that 5-day forecast out in the mid 2007, 2008, and take it back, you know, whatever, those 20 or 30 years, those that red estimate now was really only what the Southern Hemisphere estimate was way back in the beginning. So substantial improvements. Okay, we'll go to the last two organizations, GEO, the Group on Earth Observations, and WGIC, the World Geospatial Industry Council. We, in preparation for one of the UN framework conventions on climate change, you'll often hear about the COPs, the Conference of the Parties, where governments come together to talk about climate change. What we did is, to the best of my knowledge, the first mapping of greenhouse gas monitoring capabilities across public, private, and hybrid satellite missions. And you can download the report there. So the next couple slides are just going to show some of the results of that study. First of all, if we look at the mission status, and let me just back up. So greenhouse gas measurements, so it would be carbon dioxide, nitrous oxide, methane, and I missed one. All of a sudden I can't remember what it is, but what you'll see in green are those public sector missions. What you'll see in yellow are the private missions, and what you'll see in orange there are hybrid, some combination of public, private, and or not-for-profit. And then there's been one mission that failed after it got up on orbit. If we look at those mission types, same color scheme by decade, in the 90s and the 2000s, in the 2000s to 2010, it was only the public sector that was involved in this game. As we go into 2011 to 2020, you start to see the introduction of some private sector companies, one in particular that came in. And then as we go out to projections out to this next decade, it's kind of a nice mix among public, private, and hybrid missions. So one more cut at that. So this is data just looked at a different way. It's still those missions by decade. So on that last graph where it showed 100% of the missions were public, 100% of the missions were public, there still weren't very many missions. It was just 1 or 2 missions, but they occupied the entire space. As we go out here, what you'll see is the sheer number of missions has increased, both at the public level, at the private level, and at the hybrid level. So and then lastly, the mission type was carbon dioxide, methane, and then nitrous oxide. And then I think what's important here, so those were the different, these were the sensors that were on board the missions to target those specific gases. I think the important thing about the role of the public sector and private sector is that there are tremendous assets that are coming in from at a point source. So really localized places on this Earth's surface that the private sector is coming in and answering. And it can be on the optical data side. It could be on the atmospheric composition side like this. As we start to go out to a national scale, that the prevalence of the public sector assets increases. And by the time you get out to that global scale, it's largely only governments that are funding those missions. You're collecting data everywhere over the earth at almost all times. That's not to say that the private sector doesn't have capabilities to go around the earth. They do. The satellites orbit that way, but they're collecting kind of postage stamps of data. And really important ones, looking at methane emissions from landfills, you know. So the argument here is that you need that good global coverage to look at some of these global scale processes, but the commercial sector can come in with increased spatial resolution, spectral resolution, and it will complement the work that those public sector missions are doing. And so then lastly, if we look at those missions by country, you can see that the United States, it kind of dominates that particular market with all three public, private, and hybrid missions there. Many of the other countries are public sector financing that are funding those. And the one company that also happens to be a WGIC member is GHGSat, and it's a Canadian/UK company. And so that's what you'll see in yellow there. And to the best of my knowledge, it's still the only methane observations on the private sector that we have on space. So the messages that we delivered to the Conference of the Parties were, listen, these satellite observations certainly reduce uncertainty in emission monitoring. You've got to continue to invest in your government space agencies, and yet the private sector is increasingly on speed and more quickly coming into this sector. And so you ought to be putting policies in place that support public-private partnerships and collaboration. The hybrid models out of the not-for-profits are also increasing. Collaboration is essential, open data is essential, and there are just additional opportunities arising for analyzing all of these technologies and measurements. So just really important for assessment of the Earth's climate. And then lastly, and this will be the kind of second half of the talk, is spatial digital twins. Again, my former organization, the World Geospatial Council, and I'm happy to say that Brian Soliday out of Voxel Maps is here. So Brian, thanks. It's really fun to see you, a member of WGIC. We had this idea that a number of the members were in fact doing spatial digital twins, a couple in Germany. And so we said, let's put a report together that looks at the global status, the opportunities, and the way forward. And I don't want to oversell this at one point, at any point actually, because this whole digital twin arena, I think follows any kind of technology hype curve, a lot of really excitement about it. And then there's kind of like this trial of disillusionment, and people go, oh, it's harder than I thought, and it's really hard. And I'll be honest, this work was done a couple of years ago, and the mapping and the research that was done was showing we still hadn't actually bottomed out yet, you know, on that disillusionment. But at some point, it will bounce back up when people get more familiar with what's going on. So what we would argue is that it really, you know, people say, oh, I didn't actually know what a digital twin was. And I would say, you know, I think you did. It was largely in the manufacturing environment. So for a long time, we've had digital twins of automobiles. We've had digital twins of motorcycles. You know, how do they move through space? How's the airflow go around these? Those are digital twins of some physical entity. So all we're doing now is trying to move from the factory to the streets and start doing digital twins of something larger than just automobiles. So advances in technology have obviously created interest in applications. Back in 2021, the estimate was it's about $12.7 billion associated with the whole digital twin effort, with about $8 billion going for just geospatial. So the geospatial component of those digital twins was about, I guess, a third of it. And that it was projected to grow by 45 billion in 2026, with also the percentage increasing for the geospatial industry too. So that then increased from whatever it was, maybe 30% up to more than 50%. So there's space and scope here. The report had a couple different focus areas: standardization and interoperability, data sharing, public-private partnerships, and then the socioeconomic viability and return on investment. And all of this data will be available. These individual cells are a little bit hard to read, the reports in there, but what you're actually going to see is kind of spatial positioning on the x-axis, and then dimensional accuracy on the y-axis. And so by the time, so a lot of the digital twins down here are kind of some in the manufacturing arena, but as you move out and kind of up and to the right, that's where you get into what we would argue is kind of the metaverse, or this entire virtual representation of where we live. So 27 case studies, and I think, and they ranged from really site-specific ones, multi-city or larger municipalities, and all the way to state, region, country, or global. And the global example is Europe, who wants to do a digital twin of the entire Earth, and it's called their Destiny project, might be listed here. So again, Australia, kind of out there leading the pack, European Union with the most visionary, I would say, effort. Germany is there, New Zealand, Singapore. Jeff, we were talking about Singapore's efforts earlier today, and it's their Smart Nation initiative, the UK clearly, and then also the United Nations with their ocean, a digital twin of the ocean. So we've got a lot of work that's going on all over the world, and yet dollars to donuts. None of these are talking about integrating into the next higher digital twin. Resources are just not devoted to work those boundary issues. You know, they're devoted to developing the digital twin of a brain, not your whole body, or your whole body, but not how this body moves through the room. And so you get the picture. So the areas that really need to be established for better integration, and the color code by the side kind of shows at this time what we thought the current state was. There is work that needs to be done with standards, definitions, the capability and the capacity to develop them across all scales is, we may be seeing some alignment, but not much. There are absolutely use cases out there. There is indeed a level of cross-industry demand between the geospatial sector and the medical field, or any other discipline that you could think of that could potentially relate to this. And I think end client demand really is driving the development of these. So we've got to be listening to the people that need the modeling effort that would come from spatial digital twins. So the evolution would be that every digital twin across the globe, updated in real time, information flows from sensors and inputs, of course, underpinned by spatial data. The information is shared across those digital twins. So the outputs of one could be the inputs to another, and every stakeholder would have broad access to that entire ecosystem, be able to navigate their own area of interest and access the right information at the right time, at the right level of detail for what their application is. So clearly, those local digital twins, there's just a wealth of data, site or product-specific decision-making. As we bump it up a scale to the national level, I would argue, like Australia has done with their data cube, it could feed a lot more of those national applications and either regional or global digital twins, like what Europe wants to do. I guess what I would say in these closing thoughts, it's clearly challenging, and institutions, I people really do need to do a better job of collaborating. It's so hard. So much of our energy is kind of focused on our own specific work, and it's really hard to kind of jump out to the boundary a little bit and have conversations. It's time consuming. It's really time consuming, and we all are really busy. And so, and yet when you think about the time that it has been successful doing that, you know, the benefits are really, I don't know why that keeps sliding, are just immense. Long-term investments continue to need to be made by I would argue, the federal government, because you've got continuity of observations from, in the case of Landsat, 1972 up to the present and projected into the future. We need to see those landscape changes. The capabilities of the commercial and the academic sectors can only enhance and complement those observations, yet we've got to create mechanisms to have those kind of partnerships. I believe that spatial digital twins really do present an opportunity for creating a truly virtual representation of the Earth. And we ought to, you know, I maybe got influenced by Jared Diamond in his book Snow Crash, where Metaverse was actually coined, I don't know, back in the 90s, I guess. And it doesn't have to be anything different than a virtual representation of the Earth that we live in, of the universe. It's something about something, just like metadata, data about data. And we ought to be thinking about the metaverse in that construct. And if implemented, it really could serve as the forcing function that we so desperately need to tackle the really pressing environmental issues that we have facing society, but also the globe at large. So with that's it. And we got a little bit of time left. So Jeff, with time, I'm happy to take any questions. We would maybe turn mics off or on, but wherever you are in the room, I understand your question will be heard by those online. So have at it if you have questions. And I'm also here this afternoon if you're too shy to ask any questions in front of everybody. Brian, in fact, yeah, go ahead and ask your question, and then I'll definitely give you a plug. Okay.
Thanks. So one thing I would suggest is that you can run the study on a really smart people set up. Smart to download that, take a look at it. There's a lot of information there. A lot of use case things. The other thing I would throw out is that 2 weeks ago I spoke at the NVIDIA GIS, and they have a product they call it Metaverse, and they're building out this 3D digital twin, providing access to that. So that's worth looking at. And one of the amazing things of that whole conference is kids along. They're billionaire owner, right? The guy who runs it.
Oh, interesting. Yeah, good.
So there's a lot happening. Being that there's a compute team here, you know, NVIDIA is doing a lot in 3D digital twins, a lot of edge processing, building digital twins on the fly, and especially in the autonomous space. So a lot of activity there with autonomous vehicles actually building 3D digital twins with software stacks and technology stacks in the vehicle, just on the fly building. Lots of opportunity.
Yeah, good. Let me give a plug to the work that Brian and his company are doing, because he's, and I didn't know he was coming up. He's in Denver. And so what a wonderful surprise to see him when I walked into the room, because we got to know each other through WGIC. Voxel Maps is a member of the World Geospatial Industry Council. What they are doing is, you know, we are so used to, particularly with Landsat, we're looking at kind of pixels that are, you know, two-dimensional of just the land surface. What their company is doing with voxels is, let's move that on its side and look at a three-dimensional representation of volume, and from the center of the earth to above the earth, you can change the dimension of those voxels based on the data density that you have that would fit into that particular area. So let's just think about a cloud of LiDAR data, for the tree. You see the top of the tree, you see the density of that vegetation, you see the bottom of the tree, you see the earth. So if you were to cut a slice right down from the top of that tree down to the ground, you've got quite a number of data points that we would lose when you got to flip it on its side and look two-dimensionally. So their technology, I think, will actually revolutionize how we start looking at geospatial data when you think about volumetric monitoring and how this changes. So the sidebar we had as soon as I saw Brian here in the room is somehow voxel maps and the university's got to get together and have a conversation about that, because again, with the computing power that actually exists here, this would be, I think there's a lot of potential there. Yep.
Thank you for the presentation. Someone that's been in GIS for the last, I don't know, 30 plus years, I still have a hard time distinguishing what a digital twin is in difference to GIS. And then how do decision makers actually use the digital twin to make decisions? Because even with GIS, it seems to be too complicated to use to make decisions. And this seems to take it to another level.
Right, yeah.
So I'm just curious on your experience.
Yeah. I guess when I still think about a geographic information system, while we have different layers that can be represented, a water layer, a hydro layer, a city layer, for me, it's still kind of that two-dimensional approach. I know that we're starting to see buildings and three-dimensionality come into those geographic information systems. And that really needs to be encouraged, because if you were to encapsulate that, I would argue that's where your digital twin is. Okay, so that so when you look out the window, when you look at the GIS that you're using, they look alike. I'm seeing a three-dimensional representation, and I'm seeing how either traffic, that's what Germany was using it for. How, let's change one thing over there, and then how does traffic move through this entire city network? So for me, it's the 2D to the 3D jump, and the modeling or the posing of questions that then can be answered in three-dimensional space or four-dimensional with time as we're going forward. Jeff.
I can't remember when we were talking about this and if it was you or somebody else, but somebody kind of brought up the old, and to bring it back to gaming, the old sort of SimCity model, if anybody in the room ever played SimCity. And, you were sort of like doing these simulations of your city, in the real time, right? And I wonder if folks sort of might relate.
Yeah.
Like when you have these conversations, does anybody use that kind of thing as an
As-
example?
Let me ask you, does that help?
That help?
Yeah.
Yeah, for sure. For sure, but I'm having a hard time still like trying to understand. I mean, are we saying that decision makers were putting a game in front of them to try to look at the world as it happens in three-dimensional,
Yeah.
and that will help them make better decisions? And
Yeah.
that's the whole aspect behind it.
Yeah. But I think for many decision makers, you might not want to call it a game, and that's the problem. Because the gamers have dominated this, and really technical, smart people have done it. But somehow, for me, it trivializes the work that's actually been done when we call it a game, when in fact, it ought to be answering really serious questions and problems that we have.
So Jeff gave a presentation on small towns and digital twins last month, and something that I still struggle with is, in a state like Wyoming, pre-podunk, low tech, how do you plug the benefit to Hannah, Wyoming? Like what's in it for small communities to get in the game?
Yeah. Yeah, no, I think it's a great question. And probably the truth of the matter is that there'll be many localities that won't have the resources and or the data. So you're gonna be relying on what data exists across the whole state and hope the resolution is fine enough for that particular area. And so I guess I would argue is that somebody's got to step up at a level of government that's big enough and then be able to show a model that might have helped here in Laramie. And there might be some potential for impacts over there. I don't think we're going to be able to answer all the problems that they have, but at the same time, if it's flooding risk, you know, or if you look over the entire archive of Landsat data and see that actually that area has never flooded, you know, I mean, I think there's a historical perspective that will inform public policy. And I think this information provides a view into that. Let's not look at just what our memory, you know, remembers from 2 or 10 years ago, but let's look at landscape change over much longer periods of time. And that's got to help a little bit. Tom?
I'm going to relay a question from online. Camellia Akpodu asks, thank you for the presentation. Last night, I downloaded a data set from Geological Survey data for wildfire forecasting with my computational biology and botany students. I'm glad these databases are available. Can you discuss if or how digital twins might fit into genomics research?
Genomics research. So I can't. Let me be honest about that. But it was a presentation. I was sit on another board, and I was in Geneva last October, November, where out of the medical profession, they showed a digital twin of the brain. And as you looked at how that energy moved in this virtual representation of the brain, if you were a geologist or an oceanographer, you would have said, you know what, I'm looking at ocean currents, or I'm looking at these pressure waves as they're moving through the earth. You would not have known it was a brain. And so the physics are the same. And that's, I think, what really kind of just pushed me to say, we got to start breaking down some of these barriers. Yeah, you know. So can't answer specifically on genomics, but I can only imagine, you know, the data that exists in that domain and the modeling that would be done. Yeah, Karen.
So for this, you know, group of students who are looking at what their potential careers would be, did you ever think that you'd end up at USGS, or what got you into federal service?
Yeah, no, I actually didn't. I know I liked earth science a lot. You know, I probably was in 9th grade when I got turned on to that. But then in talking, actually in some conversations, it actually happened much earlier. You know, when you were talking about small rural town America, our town had, I don't know, 250 people. School went up to 9th grade and there were 25 in our graduating class of 9th grade. And we had to go to the next big town, which had 65 in our graduating class of high school. And what I realized is as a youngster, kind of just, of course, my generation, everybody was outdoors until either the street lights or the church bell went on, and that was your signal to go home. We spent an inordinate amount of time outside. And I can remember playing in a field out behind our house where there was a creek and we would build boats, sticks to race them down. And at that age, so what is that, 4, 5, 6? You know, you might not be able to articulate it, but you as youngsters intuitively knew the earth was an integrated place. That river or little stream was connected to the cow field that we were laying in. You know, the trees were there. We're looking up at the clouds, and somehow you lose it. Somehow you get into an educational system that has discipline, expertise, and your entire focus goes to that discipline. We were talking earlier today, it was Da Vinci in what we say, 1450 to 1500. Everything is connected to everything else. Everything is connected to everything else. And as best I can tell, we spent the next 500 or 600 years disconnecting everything. And now maybe it's time to kind of come back and realize everything is connected to everything else. So, no, but to the geological survey, no, girlfriend and I, after undergraduate, we're gonna go to graduate school. I had applied to a school in New Mexico, but I never really, and I still don't think of myself as an academician. I always liked work better than school. I'll be honest about that. And so we're coming out on out from upstate New York. We hit Interstate 25, and it was Cheyenne, I guess. It must have been there. And we said, listen, let's just start looking for work, because neither one of our hearts was really in going back to graduate school. So we'd stop in Cheyenne, and then we'd hit Fort Collins. Well, we get to Denver, and I happened to see the USGS is there. And so I go in, applied, and I got a job with the USGS. And spent the next 34 years with the Geological Survey. So no, there's a lot of, we were talking about spontaneity earlier today in one of our sessions, and not a lot of advanced planning. My sisters call me Mr. Magoo for just going through life fat, dumb, and happy. And that's me. So thanks. Yeah. Don't put too much pressure on yourself. I guess that's what I'm gonna say. You know what? You'll make some mistakes. Some things will work out, some things won't work out, and you can always make a change. And so I had even though I stayed for the organization for 34 years, I had many different jobs, many different locations, moved 8 or 9 times, over that 34-year period. So got to see a lot of different things. So find out where your energy is, where your strengths are, and just double down on that, because you're not going to be everything to everybody. And the sooner you recognize that, the better off you are. And it'll drive what partnerships you establish too, because you want to partner up with somebody or other colleagues who have strengths that you don't have, to make the team stronger. Yeah.
Thank you for your talk. As others have said, I was wondering what's an example of a digital twin that has gotten you excited, or you saw it and like, wow, that is just the coolest thing ever.
Yeah, no, probably this one about the brain that I saw in Switzerland. Yeah, and not so much about how what they were specifically saying, although they were trying to diagnose changes in brain patterns, because of diseases. But for me, it was immediately jumping to, I could be looking at ocean waves, or how an earthquake propagates through the land surface. So that one I would have to say, yeah. Yeah, Jeff.
I have one more question. So we talk a lot about sensors and satellites and collecting that kind of data. I think oftentimes the challenge for a lot of us is how we sort of track humans and human behavior and the dynamics of humans. What's your sort of take on the industry now in sort of how we should or shouldn't be tracking humans?
Yeah.
And how does that kind of get tripped up by concerns about privacy and, I don't want to be in your digital twin.
Right. Yeah. Yeah, no, listen, and I think particularly, we were talking about it earlier too, on this whole AI thing. Listen, there are risks. There are absolutely risks about these efforts being abused. And and I guess I'm just kind of optimistic that we could put some checks in space so that there's an ethical use of that anonymization is used, because you do want to see patterns that humans are doing collectively. I think has a lot to do with the issues of climate change now, that collectively we're having an impact. So I honestly probably err on the side of being a little bit more open and think, hey, bad things are going to happen, but let's try and kind of minimize those. And I absolutely know that's not where a lot of people are. And you end up getting burned too, because some bad things do happen, but we tend to be, I think in general, we tend to be maybe a little bit more risk averse, and maybe rightly so, but by getting caught in that risk averse strategy, I think we are selling ourselves short on the tremendous benefits that can come from that collective behavior.
Yeah.
So that's kind of where I am on it. But.
So every scientist needs a gamer friend.
Right, right, right.
And I love what you said last night about, that people in gaming aren't afraid.
Oh,
They're afraid to die, right? They're
yeah,
afraid
yeah,
to,
yeah. Actually, we talked about,
trying to get to that level
No,
and then
you're
just
right.
crash and burn.
Yeah.
Because they can do it all over.
yeah,
again.
yeah, we
And then,
did.
like, and that's like a whole mentality.
Yeah,
right,
and that
with
came out of
games.
this morning's conversation, I
Yeah.
think with Emma, and it's exactly right. You know, I mean, what better place, right, to fail?
So how
And
do
fail fast.
scientists, how scientists, how do we sort of embrace that risk?
Yeah. Well, it's hard. It's hard. The story that I think about, just real quickly is, worked for the US Geological Survey, and I spent 20 years in the water division. It wasn't until the last 14 years that I moved over to mapping and, geography. And, we had, a measurement down in, somewhere in Georgia, some river in Georgia. The stream flow measurement was taken in 1898. And there'd been, 50 more years of data. But this one particular measurement had a lot of influence over where you drew the floodplain. And so a developer came in and challenged that one stream flow measurement that was taken in 1898 and said it's got an undue influence, over where we're drawing the floodplain. So first came to the water division and challenged it. And we said, hey, the measurement's the measurement. And then it went to the director of the Geological Survey. And then I happened to be in a job downtown with the Assistant Secretary for Water and Science when all this was going forward. Finally, this developer and his lawyer got as far as the Secretary of Interior. And we were going to have to call in one of our experts on stream flow measurements, a wonderful, brilliant guy, Bill Kirby. But Bill was a scientist. And what these politicians needed was a black or white answer. And Bill was not capable of saying yes or no. And so the best example was, it could be as white as this tissue, or it could be kind of off-white, Bill would not say it's white because the answer was it's off-white. It's not white. And so I guess where I'm coming around to is it's very hard for scientists with all of our, one being relatively risk averse and often not being able to really jump to the end game to say, what's the intent here? Now, it's not white, but it's sure a hell of a lot closer to white than black. And so what you're asking me to do is jump all the way to the black answer, and how many thousands of people would be put in harm's way because you're saying this one stream flow measurement was enough to change the floodplain. It wasn't, it wasn't. It was a pretty good measurement. But because you couldn't remove 100% of the certainty associated with that, our key water person was not able to say it's white, And I think that's, not, yeah, I think that's just systemic of our field. And there's some really good, wonderful things about that, that Bill was so principled, he just couldn't quite go that next step. But at the same time, I don't think we fully understood by not going to that next step and at least saying it's sure closer to white than black, that actually way more people were gonna be in harm's way by changing that, And plus we had 100 years of record, but not quite after that, 75 years of record. So anyway, long story, but that's it.
Any other questions?
Oh, okay, got Nick.
Okay,
And maybe one here open. Oh,
I'll try to make it quick. It was a little bit of a compilation of what we were talking about in previous, like, Wyoming base map, and now, like, with the digital twin. Where do you think, and how would you envision, I guess, that effort, like, getting off the ground, or them being like, oh, that might be Nate, or I don't see the valley, like, who should lead that, and how would we herd all the cats involved?
Yeah.
Like the school computing, NCAR, the university maybe, or like outside private organizations, by Geo, like,
Yeah.
how could we who should lead that effort, or how would we do that? Like, where would you envision the best way
Yeah.
to start on something like that?
Yeah. Well, whoever said it, you know, the journey of 1,000 miles is the first step. So you absolutely, what I would do is at least kind of identify who you think have got, you know, some stake in what could be done or capabilities that you need. So at least get those people together. I'm not saying that'll be easy because I think, again, it's kind of almost unnatural for different institutions, you know, to work together. Get that. But I think that's an easier story with people that kind of get how geospatial is, I mean, how the Earth system behaves. I think that's a little bit of the easier sell. For me, the hard part is we've got to find a political champion. So whether it's Governor Geringer because of this, or at least talk to him about some advice that he has, because he does fundamentally understand how geospatial information can help people. But you've got to get somebody that's willing to carry some water and put some political capital into it too, you know?
He famously told us he wanted us to come to him with a solution. So
Yeah.
Does that mean we build the digital twin first and then say?
No, I don't think so. I think you still got to kind of paint a little picture for them and say, listen, this will get there, but you're going to need political support to even bring some of the private sector parties to the table, or some other parts of government that you maybe haven't thought about. And that political voice can help that a lot, can pave the way. You still got to make the sale, but you need some support for sure.
Last hand up, is it still up? It
Yeah,
wasn't
Patty.
your hand, Patty.
Oh, yeah, no.
Stretching.
Okay.
Last,
Want me to ask now?
yep, last one. You get the last word, Patty.
So I have a quick one. Again, thanks very much for your talk. From the talk, it seems like most of the digital twins out there are focused on representing quantitative information. Are you aware of any digital twins that are integrating qualitative information such as local perspectives? Or
No, yeah,
flooding,
great.
those kind of.
Yeah, that's great. Great question, and I'm aware of none. I'm none. It's all kind of on the physical side, you know? There might be one example where it was a digital twin of a room and they put people in the room and then monitored heat in the room based on bodies kind of being there. So it might have been a sense of, okay, how are they feeling? Getting hot, getting cold, whatever. But no, not anything as deep as what you're proposing, and that's good.
This is the great thing about interdisciplinary. We have a spatial cognition specialist that chairs the faculty advisory group for the School of Computing. So ears are perking up. Because yeah, that's a really interesting question about how do you sort of model human behavior, right? Yeah. Listen, please join me in thanking Barbara for her comments. This is a really great.
Thanks, everybody. Appreciate it. Thank you. Thank you. All right. All right. No, thank you, Jeff.
Have a great weekend, everyone. Yeah.
I gotta go back.